Okay, let's see how we solve the problem related to the method of join. Problem number one, determine the force in each member of the truss shown in figures and indicate whether the members are in tension or compression. So in order to solve this problem, we need to dismember the structure and we draw a free body diagram to each members and each joint from point A, B, and C. Then we will set all the members whether in tension or compression. If we don't know whether this is a compression or tension, so we will put them as a tension diagram. So we all know that one of the members is in compression, so we will stick to the compression and the rest is in tension. So if we look through, there will be two conditions in order to solve this problem. The first one is predetermined compression members at figure number one, and the second one is if you don't know whether the tension or compression, just put all of them in tension. But first, we will try to solve the problem by using figure number one. We are trying to solve this problem by using method number one, whereby we are using only net force is equal to 0. So another method, which is method number two, we will combine to use net force is equal to 0 and also moment at a particular point is equal to 0. If we look through joint A, B, and C, so we will determine how to choose point a joint, which one is easy or not. So we will start from joint B because of less unknown member force, and unknown force we know that there is a 500 Newton. So at point B or joint B, we have this free body diagram, which is 500 Newton to the right, and then we have FBA downward, and also we have FBC is 45 degree upward. And we need, if we arrange it from starting from the origin of B, we will have uh, another diagram. And if we solve this problem by using the net force is uh, equal to 0 at axis, so we have 500 minus FBCX equal to 0. So the value of FBCX is supposed to be FBC cos 45. And if we minus 500 Newton minus FBC cos 45 is equal to 0, and finally we have FBC equal to 1707.1 Newton, which is a positive value. So we agree there is a compression taking place at this member. In order to get the value of FBA, we do sum of Fy is equal to 0. So that means we have FBCY minus FBA equal to 0, and finally we obtain FBA is equal 500 Newton, which is predetermined. This is the member in tension. So finally we have a value of positive 500 Newton. So next we proceed to solve this problem at joint C. So we have this kind of free body diagram, and if we make arrangement starting from the origin, so we have the FBC is 45 degree to the downward. By using the summation of fx is equal to 0, so we have the component of x of FBC minus FCA is equal to 0, and we know that the value of BC is 707.1, so we substitute inside and apply for cos 45 degree minus FCA, and finally we obtain FCA is equal to 500 Newton, which is the positive value, and we agree that there is a tension. And for applying for the summation of Fy is equal to 0, so we have these two components from the Cy minus FBCy equal to 0, and finally we obtain value of Cy is equal to 500 Newton. This is the reaction force from the roller, so that no need to put intention of compression here. This is next we will proceed to calculate at joint A. As you can see, there is a free body diagram of joint A, which is AX, AY, FBA, and FCA. So from the previous calculation, we obtain the value of FBA and FCA is equal to 500 Newton. So in order to get AX, so the value we can obtain by using the net force is equal to 0 at X axis. So we obtain the AX equal to 500 Newton, and also with AY at the same value. So the final analysis or calculation, we can summarize by using the figure shown. So whether the members is tension or compression can be stated here, and also the value of each joint. So in this method number 1, we just use a simple method by using a summation of net force is equal to 0, whether x axis or y axis. Okay, there is another method, which is method number 2. So that we can solve later on. So in method number 1, if we choose the all members is in tension, so there are different calculation but the same technique. So let's try figure number 2, which all members are set on tension. So if we that's one we assume from the assumption from the slide number 29, which is all, if we don't know whether is the member is compression, so we just state that all in tension. So what happened to the value, we will only get the sign of positive or negative. So let's see the process. Okay, if we set the member in tension, so FBC supposed to be uh, towards 45 degree to the downward. If we use a summation of fx is equal to 0, so that means we have 500 is plus fbcx is equal to 0. FBC can be calculated and we can get the value is negative 707.1 Newton. So this value is opposite direction. So that means once we preset the direction and we obtain the value is negative, so the value is supposed to be positive and the original preset value is basically wrong. So we need to redraw to the opposite direction. So that means if we set this value is in tension and we get the value is negative, so that means the correct value is in compression. So let's see how to get the answer by using the method number 2. So the method number 2, we will use two equations where is we use the net force is equal to 0, and another one is by using the summation of moment is equal to 0. In order to solve this problem, first thing we need to separate it how to solve by using analyze from reaction and external forces. So the first thing is we determine the external forces. In this figure we have 500 Newton is external forces, and then the reaction force is come from the AX, AY and CY. So those information we will use the net force of Fx and Fy to obtain the value of whether the AX, AY and CY. So for the Fx is equal to 0, we have 500 minus AX. So we don't have any X component come from Cx. We don't have any Cx. So we have only 2 from 500 Newton and Ax. So both this is opposite direction for preset of tension and tension. So we have 500 minus Ax is equal to 0, and finally we have Ax is equal to 500 Newton. So once we get the value is positive, so this is the true preset of arrow or direction of Ax. And then we proceed for the net force at y-axis is equal to 0. We have two forces from the AY and then we have CY. So both direction is opposite direction, whereby CY is positive value and AY is negative value. So CY minus AY is equal to 0, and we obtain that CY is equal to AY. And here we will proceed by using a moment, okay, whereby net uh, moment or summation of moment at certain point, whether point A, point B or point C is equal to 0. But this one, in this case, moment at point C or point A we can proceed, but if we want to proceed by using at point B is quite difficult. Okay, so we will choose the a point which is very easy to solve. Okay, so by using moment point joint A or joint B is joint A or joint C is okay, but joint B is quite difficult. So I will proceed for a moment at joint C first. So let's see. So moment at point C, okay, we by using a counterclockwise direction as a positive value, so we will have two forces act on that. The first one is come from 500 Newton, and the second one is from the value of AY. Okay, two forces acted on this moment. For the force at AX is zero, okay, because there is a no distance, okay, no distance. So at point B we have 500 Newton. So the distance from B to axis of horizontal, we have about 2 meters. So, and the value of 500 is clockwise. So during the moment we set for the anti-clockwise or counter-clockwise is positive. So 500 supposed to be negative. So negative 500 Newton times 2 meter and minus plus AY is according to the direction of moment, which is plus. So AY is positive, and the length or distance from point C is 2 meter. So finally we have the value of AY is equal to 500, which is positive value. So that means the direction we set downward is basically true. Okay, correct. So and then we already have CY is equal to AY. So that means CY is the same value as AY. So that means CY is equal to 500 Newton. So let's say if you don't want to proceed by using moment at point C, you can choose at the start from the point A. So if you use start from the point A, you will get the value of CY. So the value of AY and AX is already omitted. Okay, and then we have only CY involved in the calculation. So finally, if you proceed by using this point, you will obtain the CY first. So that means you obtain CY is equal to 500 Newton, and then you substitute to CY equal to AY, and finally you obtain AY also the value of 500 Newton. Just now we see how we determine the value of a reaction forces, which is AY, AX, and CY. So here we will continue to proceed the forces act on each member. So at we have 3 points. Okay, whether we want to start at point A, point B, or point C. So let's say we choose at point A. So basically, when we choose each whether point A, B, or C, we try to choose at point whereby we can solve this problem, which means that uh, the unknown force is less, or we can solve very easy with less forces. So if we look at point A, we have four forces acted on this point. We have AX, AY, which is 500 Newton, and we have FBA and FCA. So from this point, we can easily get the value of FCA, which is equal to AX, and also FBA is equal to AY, straightforward. At joint B, we have external force 500 towards to the right, and also we have the FBA and FBC. So in order to solve this problem, okay, basically FBA we obtain 500, so only FBC left. So by using the net force of x-axis is equal to 0, so we have 500 minus FBCX, and finally we obtain FBC is equal to 707.1 Newton, which is the positive value. So that means this is the compression takes place on this member. Okay, and finally we draw a complete diagram indicates that tension and compression and all forces acted on each joint. Let's see for the problem 2, which is we have a different diagram, and then one external force which is to the right direction at 48 kilonewton. We have a pin and roller. So in this problem we need to uh, state whether each member is in tension or in compression. So basically the first thing you need to do is this member, this diagram, and then you try to draw a free body diagram on each member and each pin or joint. So we have joint A, joint B, and joint C. In this problem, we cannot straight away solve this problem by using the net force is equal to 0, the same as problem number 1, because of each point cannot simply solve by using this technique. So we need to use another method number 2, which is the existence of moment at certain point. Okay, so in this problem we will analyze from reaction and external forces. Okay, so from the reaction and external forces, we know that we have a reaction is from Bx and By, and then we have Cx, basically Cx, and then we have 48 kilonewton. So by using the net force at net force at y-axis is equal to 0, we obtain the value of By is equal to 0. So that means there is no force act on By, only Bx. So and then if you proceed to use a net force at x-axis, so we have three forces act. We have 48 kilonewton, you have Bx, and you have C. So difficult, you cannot determine the Bx direction because you preset the Bx towards the right. Maybe Bx is toward to the left, or Cx is toward to the left, we don't know. So by using net force at x-axis is cannot determine the value. So only net force at y-axis we can simply get the value of By is 0. That means we don't have any value at By. And then we proceed by using the moment at point C or point B. Okay, if you which one is okay, but if proceed by using at point A is very difficult. So you can start there. Okay, so let's see we solve this problem by using moment at point C. So we have 48, which is opposite direction of which is clockwise direction. So we put negative bx at the distance of 3.2 meters. Okay, and then we have 48 also the clockwise, which is a negative 48 kilonewton, and the direction the distance is 7.2 meters. So by using bx, you solve this problem, and finally we obtain the bx value is negative 108 kilonewton. Once you get the value negative, so that's mean the preset of direction you set to the right is actually wrong. So that's mean the bx is to the left. And also, in order to get the value of c, so we will do the net force of fx is equal to 0, and this one we have three forces acted on each point. So we have c is positive preset, we set a preset positive to the right, and minus 48 to the right also, and then we have a bx value is to the left, so we minus bx, and finally we obtain the value of c is negative 60 newton. So once we get the value is negative, the actual direction is supposed to be opposite direction, so cx equal to the to 60 newton is to the left. So the actual forces acted on each point is supposed to be the new diagram. So remember that all members we set, if you don't know the compression or tension, you will set all in tension. So in this case, you will set all in tension. So originally we don't have any by. So and then we have bx and c is supposed to be to the left. So in order to proceed to solve this problem, we can start whether you want to start at joint B or at joint C. Okay, if you set at joint A, is quite difficult. Okay, and you start there. So at joint B, so we have a free body diagram is something like this. Okay, and you can proceed by using the net force at axis is equal to 0, and finally you will have fbax minus bx is equal to 0. For the fbax, which is we have fba cos theta minus bx is equal to 0. So cos theta, in this case, there are two kind of uh, solution, whether you want to get the value of theta first by using the dimension given 4 meters, 3.2 meters, 3 meters. So, or whether you want to proceed by using a triangle, okay, which is we have this triangle is 3 4 5. So theta, in this case we don't want to get the value of theta, so we just obtain the value of cos theta. So the value of cos theta is 3 over 5. So we just substitute the value of 3 over 5 minus times FBA and minus 108 kilonewtons. So Bx we already calculated from the previous slide. So finally we will obtain the FBA is equal 180 kilonewton, which is this one is positive value. That means when we preset, this is the tension, and we get the positive, this is the true. okay, true value. And then for the value, in order to get the value of CB, so we will use the same technique whereby the summation of at force at y-axis is equal to 0. So now we have FBA sin theta minus FCB. So by using the same triangle, so we will substitute the sin theta, which is 4 over 5, in this equation, and finally we obtain FCB is in positive value. So this value is tension. Okay. Okay, another method. Okay, in this method by using triangle. Okay, if you once you know the triangle consists of forces. Let's say we have FBA, okay, and then we have FCB, and then we have 108 kilonewton. Once you arrange the forces acted on point B as a triangle, so you can proceed, you can solve this problem by using triangle. And this triangle, you can see FBA is equal to 5, okay, 5 meter. FCB is equal to 4 meters, and 108 kilonewton is equal to 3 meters. So you can make something like this. So in three equation, we have FBA divided by 5 equal to FCB divided by 4 and equal to 108 kilonewton divided by 3. And finally, you will obtain the value FBA and FCB also. But by using this technique, you just only get the value. Okay, the positive negative is not uh, produced, so you need to predetermine whether this is positive or negative. Okay. Okay, by using the same technique, okay, at joint C we have this triangle, and then this triangle can determine the cos theta. The cos theta is equal to 3 over 7.8, and finally we obtain CA value in tension. Okay, let's proceed to the problem number 3. Okay, quite different diagram structure, and then of course the question need us to determine each member whether in tension or compression. Okay, by using the same technique, by using the net force is equal to 0 and moment at a particular point is equal to 0. So firstly, we need to determine the free body diagram at each point, whereby we have a roller and pin. So at point A, we have two forces, okay, reaction forces at AX and AY, and then we have C. Okay, so by using the Fy is equal to 0, so we have two forces acted on Fy axis, which is two external force 2.8 kilonewton, and we have a AY. So both from the direction is to downward direction. So both all is negative at equal to 0. So and finally we obtain the value is AY is 2.8 kilonewton. Okay, whereby the value of AY is opposite direction of external forces 2.8. So that's mean when we preset is downward direction, once we get the value is negative, so the actual value, the actual direction of AY is supposed to be upward direction. And then by using a moment, okay, you can use a moment at point A or point C. Okay, in this case we will choose at point A. So at moment at point A, we will have we will obtain the value of C. So the C is equal to 1.5 kilonewton at at to the right. Okay, and for the value of AX, we will obtain by using the Fx equal to 0. And finally, we have AX value is negative, so the preset is positive to the right. So once we get the value negative, so the actual value is 1.5 kilonewton to the left. So and finally, we rearrange the direction and we will direct this diagram. So in order to get whether the tension or compression in each member, so we will proceed to go analyze at points, okay, or joints. Okay, we can start at joint C or A, and if you go for point joint B, is quite difficult. So we will go in this case we will go at joint A. So at joint A we have FAB. Okay, remember, so all those if you don't know, we set all those member in tension. So if in tension we have a FAB and FAC. Okay, basically is away from the or point A. Okay, but once you set as a tension, basically the direction is away from the point. Okay, so we have FAC downward and FAB at a certain degree to the left to the right. Okay, so and then you proceed to net force equal to 0. Okay, whereby here we have FABX, where FABX is FAB cos theta. So cos theta, here we have a triangle. In order to get the cos theta by using this triangle, so we have substitute 0.75 over 0.85, and finally we have FAB equal to 1.7 kilonewton, which is the positive value and supposed to be tension. And we proceed to get the value of FAC. So the FAC, we have three forces acted on this point. We have FAY, AY minus FAC minus FABY. So FAY we got from the previous slide, 2.8 kilonewton. FAC we want to get this value, and we have FABY is FAB sin theta. So sin theta we can proceed by using the same triangle. So we get the value is 0.4 divided by 0.85, and finally we obtain the value of AC is equal to 2 kilonewton, which is positive value and its tension. And then we proceed to look at a joint C. So at joint C, okay, maybe if you want to rearrange the point whereby you set starting from the origin of point C, whereby the force is away from the point C, so you can arrange the diagram like this. So and then you apply for the net force at axis is equal to 0, and finally you obtain the value of FCB is minus 2.5 kilonewtons, which is the opposite direction. So whereby once you set is tension, so and then you get the value of negative, so the original is a compression. And then if you want to solve this problem by using the triangle technique, so whereby you have forces, three forces, and you rearrange it to become a triangle. So this one is a setting is something like this. This one basically we don't know the value whether is compression or tension. So this value is basically you obtain just perfectly for the value. You don't know whether the compression or tension. But if you know this kind of member is compression, you just stick uh, the direction. Okay, you arrange the direction. Okay, and finally, if you want to look at the complete diagram, indicates all those uh, forces acted on each point, and whether the tension or compression, you can do something like this. Okay, for problem number 4 and exercises, so maybe you can try yourself and find out. Okay, if any problem, please let me know. Okay, thank you very much.